This is Ted Howard. I'm going to try something new here. The conversation on GitHub the other day around promises and is there any real value in them at all was an interesting discussion. And in that, you posted a link to some code that was particularly hairy to write and kind of read through and understand. And it uses callbacks. Not that it was difficult to read through and understand because it uses callbacks, but just because the logic itself that it's doing is kind of a complicated situation. We were trying to find use cases where maybe promises would actually help clean some of it up, make it easier to read. Again, knowing that a lot of these programming uh, values that we talk about, good code or bad code or clean or dirty or nested or spaghetti or whatever, are as much fashion and personal preference as they are about real benefit. But nevertheless, I wanted to take a shot at it. And I started looking at this code the other day and began kind of working on some changes and updates just to see what it would look like. And I thought about sending you the file over, but I realized that I think it would be more beneficial if I could walk you through it. So I've never done this, but I thought I'd give it a shot and make a screen recording here of my code editor and make the changes live and just kind of talk through what I'm doing. And then when we're done, we can look at it and we can see, is this better? Is this worse? Is this the same? So anyway, looking at the file here, like I said, I've looked at this already. You've got a few functions that export here, reading OPML from a string, from a file, from a URL, and then your outline visitor method. You got your imports. You have this data, which apparently isn't being used, which is fine. And we have some utility functions for getting booleans, name, attributes, node types, copy scalars. Okay, here's the outline visitor. This is the one where I really want to spend some time digging in because this is the one that takes 1, 2, 3, 4 different callbacks. And then inside of it has several nested functions itself that make recursive calls to each other. So here's do level calling itself, and do once actually do level calling do one sub, which calls do level, which calls do one sub, etc., etc., etc. With these different callbacks up here, basically providing notifications for different states. So this, if I've read this code correctly, iterates over an entire outline. And every time it reaches a node that has children, it descends and iterates over all of the children. And then once it's hit the end of those children, it rolls back up to the next level and continues going, so that you get a full iteration of the entire thing. We have callbacks that basically notify us when we enter into a new level, when we exit a new level, and then one for every single node. And I can see where they're referenced here. Like here's the node callback, and it always passes into it the actual node itself and then this string path that is built up, looks like here, by being concatenated from a path that's passed into do level plus whatever the name is of the current node. So that's what we have here in this. Let's pause on outline visitor for a second though and come back to it because this is the really hairy one. Let's do the simple functions first. Okay, so for example, here is expand includes, which takes in an outline object, a callback, and then a flag whether or not to stop at docs. And it returns via the callback the fully expanded outline, and it uses the outline visitor to do that. So because the topic of this is seeing if promises make things better, let's change this function to use a promise, or rather to return a promise instead of accepting a callback. So the way we're going to do that is we're just going to go return new promise right here at the very top. And the new promise constructor takes a function that has a resolve function and a reject function. Okay. And we're just going to come in here and we are going to copy everything that was there. We're going to put it inside of the promise constructor, fix the indentation. Okay. All right, let's see. Callback is only referenced down here in the success case. So this is going to be a call, set up to callback to the resolve function. And that's it. Now expand includes returns a promise that when it resolves contains the new outline, the expanded outline. So I'm going to go ahead and erase the callback, and now that I've changed this function signature, I'm going to find all references to this function, and it looks like there's one up here at the top, and we're going to update them to use the new signature. So here's expand includes. All right, so what we need to do is this Boolean value is now the second parameter, and then that's it. And then we say dot then, and everything else can stay the same. Okay. And then let's come down here to the other call to expand includes. We'll do the same thing. It just looks like we're just passing false in for that flag. That's fine. Then, and clean that up. Okay. All right, so there's expand includes. It's using promises, and everything should still work as it did before. Great. So that was expand includes. Okay, read OPML string. All right, same thing. We'll just start right here at the top. Return new promise. Resolve. Reject. All right, and this is a long one. We will copy everything into the promise. And whoops, whoops, there we go. Let's update the indentation. Okay. Great. And let's see, where are we referencing the callback? Here, OPML cursor.on error. So this is an error state. So we're going to use the reject and give it the error. And then we can take that out. I don't need to check to see if it's undefined because the promise constructor is always going to give us a valid resolve and reject function here. Where else are we calling the callback? Okay, down here, if, okay, oh, all right. So same thing in here, we can just say resolve expanded outline. And then here, resolve the outline. Trying to match the formatting of the code here. Okay, is that, where else is this callback being a reference? Oh, because I had it in the undefined check. We don't need the undefined check anymore. Okay. And now our callback is declared but never read. Perfect. All right, so let's take that out and we change the signature. So let's find all references to this function and update those. And there's two. There's one in read OPML file and there's one in read OPML URL. Okay, so again, really quickly here, this Boolean is now the second parameter. Comma, then callback. Okay. And same thing down here. Callback. All right. Cool. Let's turn off the notifications. Okay. All right. So now that, okay, read OPML file. Let's make that a promise. Let's make that use promises. Okay, the way we're going to do that, because we're using fs read file, I'm going to come up here to the top and I'm going to import the util package from Node. util has a function on it called promissify, and you can pass in any function that takes a node style callback, like fs.readFile, and it returns a version that uses promise. So I can just say const read file, and this is fs.readFile except with promises now. So if we come back here, I can say return read file. I can give it my file, and that returns a promise of a buffer, right, which is what read file provides in the callback. All right, so we're going to have a .then, which will take in the data, and then we're going to have a .catch, whoops, which will handle the error. And then let's just copy this code. So here's your error handling code from down here. We'll put that in the catch block. And here, instead of callback undefined, it's just return undefined. And then in the success case, let's bring that up here to the then block. Okay, we don't need to do .then callback anymore. Instead, we can just say return read OPML string, because that returns a promise that will cause it to unwind. And now read OPML file uses promises. Okay, let's do the same thing for read OPML URL. Okay, you're using request. Cool. There's a promised version of that too, but I'll have to npm install it. And it's called request promise native. And let's come up here. We'll just say RP for request promise. Require request promise native. Great. Same thing here. We will say return RP, give it URL outline, and then we'll have a then function that takes in the body. And we'll have a catch that handles the errors. Okay, so here's our error handling. And in the success case, you have this status code check because it needs to be 200. So we can also, request promise actually causes those to be errors as well. So what we can do here is inside of our catch block, we can say error.name is status code error. And I know that because I read the request promise docs. Okay, so we can put that, and instead of response.statuscode, it's error.statuscode. And then we can just say right here in this return undefined. And because we have a return statement here, we don't need to make an else block. Those will execute. Now the success is a call to read OPML string, and it has a .then callback, which we can take off and just say return. Okay, and then I can delete that. Cool. Oh, and we need to change these signatures, and we need to update any code that calls them. So let's do read OPML file first, find all references. It's no references in here, it's just exported. So read OPML URL, same thing, find all references. Okay, it's exported and it's called once here in outline visitor. Okay, let's see. Then, and okay, and everything is fine. Great. Okay, so that, I believe, is the end of all of our quote-unquote simple ones. Expand outlines returns a promise. read-opml string returns a promise. Read-opml file returns a promise. Read-opml URL returns a promise. Okay. Now we've got the hairy one here, the outline visitor. Let's go back to expand includes and let's take a look at how this is used, because that's the function that calls outline visitor. Okay, so it defines an in-level callback, a node callback, an out-level callback. And up here at the top, we have the new outline, which is a new object, the last node, which points to that same object, the stack, which is an empty array, and current outline, which is undefined. So in-level callback, we take current outline and we push it onto the stack. And then we take last new node and we set, so current outline now points to last new node. And then if current outline subs is undefined, then that's a new array. That's the in-level callback. And so I bet the out-level callback is like a mirror of that. Current outline is, yeah, so you pop whatever was on the stack and you set that equal to current. Okay, so in-level current outline goes onto the stack and it becomes the last new node. Out-level current outline becomes whatever was previously pushed onto the stack. And in the middle, there's this node callback, which creates a new node, which is a new object, copies the scalars from the node that's passed into it onto the new node, and then pushes it onto the subs array of the current outline, which was initialized at in-level callback, and sets last new node equal to the new node that we've created. Okay, so that's the effect of every time we hit a node, every time we process a node, we have a reference to the most recent processed node, so that if we're going to go in a level, we can make that current outline the node. Okay. And then finally, we have the closing callback, which calls our resolve function. Okay. So when I look at this, what this looks like to me almost is if our outline visitor is like an event emitter, because where it gets giving events off to say, hey, I've just entered a new level. Hey, I've just processed a new node. Hey, I've just exited a new level. Other thing that it does, and I said this before, is that it iterates an entire node or an entire outline, going nesting all the way down into all of its children. So it would be nice if we could do something like this. If I had like for const node of the outline, right? If I could just use a for loop and iterate over the outline and get all of the nodes, then, right, I could do everything in my node callback right here. Let's bring these variables into this scope. Okay, right, that satisfies this part, but I also need the in and the out. So it would also be nice if I could do something like the outline dot on in level. And the outline dot on right, because these really are kind of like just events that as we are iterating over the outline, these things happen. It's not actually passing us back any data, it's just saying this happens. So if we could move that code in here, and we could move this code in here, right? So it's like we could listen on the outline for level events going in, going out, and then otherwise we could iterate all the way over it and get the node for every single one of these. Looks like it also gives us the node and the path, so I could maybe like this. This code won't work right now. This is like my fantasy programming, which is sometimes how I think through problems. I write the code that I wish I could write, and then I work backwards to see if I can make this work. And of course, finally, we want to return the new outline. Right? We create the new outline, then we register these listeners on the current outline, then we iterate over the current outline, and the result of that is it's made this new outline, and then we return it. So now the question is, can we actually make this code? And the answer is yes, almost. So we're going to use two different tools. One of them is provided by Node. The other one is a language feature in JavaScript. The Node tool is the event emitter, which gives us the ability to fire these events and register listeners using .on. And the language feature is our iterators and generator functions. Basically, JavaScript gives us a syntax that lets us create our own iterator objects that can be passed into for of loops that can allow us to define any sort of iteration that we want to. And so that is what we're going to do now. So here's all the logic that we're going to need that tells us how to do this iteration. And right now it's done using these recursive function calls to do level, which descends down to a new level, and do one sub, which I guess really it just processes a node and an index. But a call to this function is like one iteration in the loop, and you can see pretty much at the end of every single logical tree of execution, we have a call to do one sub to get the next one, which we have to do until we've finished a level, and then we call that callback. So, okay. So we're going to take this logic and we're going to try to put it into a generator. So what I'm thinking we'll do here, whoops, let's come outside of Outline Visitor. We're going to want an outline generator. And an outline generator is going to be a JavaScript generator function. It is a special, again, language feature that you declare using the function keyword followed by the asterisk. It kind of looks like a C-style pointer, but it's not. It's a generator function. And this actually returns a generator value. Let me show you here. I have a function outline iterator as well. We're going to wrap some logic in here. So I could get const it equals a call to outline generator. Right, and you see there's no body in this function, but I put that asterisk there, and so it is not void, it is a generator. And I could actually take it and put it into a for loop and iterate over it. Of course, it's not going to do anything because there's nothing in here. All right, so the other important piece of a generator function, let me fix my indentation, is the yield keyword. The yield keyword is how we pass values from the generator, from the iterator into the loop. So again, real quickly, if I were to say, how do I get a node object here? Well, the way that you do it is by yielding it. So I could come in here and I could say node is a new object, and then I could say yield node, right? And I could do something with node. And here, node is this object that I've yielded. This loop has one call to yield, and it's going to therefore just have one iteration. Now I could come in here and say yield, 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 yield. This loop will actually execute 1, 2, 3, 4, 5. It will go 5 iterations because it has 5 yields. So you kind of see this little abstraction here that allows us to have as many iterations as I want. And of course, I can put yield in a loop. So I could come in here and say for I 0, I is less than 5. right? Like that. Now I'm going to get 5 iterations because I have a for loop with 5. So this is going to let us, if we can unwind the logic from outline visitor, to iterate over the entire node, and we can call yield every time we would call node callback, we'll call yield, and that will let us pass this value into our for loop, which is going to allow this code here and expand and includes this for loop right here to work. All right, so let's do that. All right. Oh, the other piece is the event emitter, and that's why I created this other function. So event emitter is something that's provided by Node, and it's inside of the events package. So require events, and then in outline iterator, I must have, okay, I can say event emitter equals new events dot event emitter, like that. Okay, and so the object we want to return is both this iterator and the event emitter combined. And so what I'm going to do is I'm going to take the iterator and I'm going to give it an on function. That will take an event and a listener because we'll use the closure here to call event emitter dot on, passing in the event and the listener like that. And then we can return the iterator. Okay. And this iterator should take an outline object. So down here, this code updates just a little bit now because we're going to say, we'll just get our iterator. It equals outline iterator, and we'll pass in the outline. And so now that becomes IT, that becomes IT, that becomes IT. Okay. There's our generator. There's our on function. And there's our loop. Okay, so the basic plumbing is in place. We still have all of the work to do. Okay, so what does this outline generator need to work? Well, it's going to need access to the event emitter. It's also going to need access to the outline. And it's going to also need the stop at docs flag. Okay. And let's get rid of that code here. And what we're going to do is we're going to just bring over some of these existing things. So we have like this read include function, and this type is doc function that are used internally. So let's just going to copy and paste those up here so that we have them here. Read include and type is doc, and of course read include takes a callback. You know what, let's make this return a promise because read-opml URL returns a promise already. So if I add a returns keyword here, and then now inside of my dot then, in the callback, I can just say return undefined. And then here, instead of doing a dot then and calling a callback, I can just return that call to expand includes. And then now that no longer uses a callback. So read include is now a promise of the expanded outline. Great. All right, I'm going to collapse those. And I'm going to collapse this as well, just so that I can see here. So let's collapse that and collapse that. Okay. Do level. Okay, so what's the very first thing this does? If stop at docs is undefined, stop at docs is true. I'm going to use this JavaScript language feature that lets me set default values to function parameters, and that will take care of that. If no value is given for stop at docs, then it's going to be assumed to be true. Okay, so we start with a call to do level, passing in the outline, the path is an empty string, and then the function. All right, one difficult thing about generator functions is that we can't actually call yield from within a nested function. So let me just show you here inside of typist doc. If for whatever reason I wanted to call yield true in here, this actually wouldn't work because it's inside of this function. The yield is directly bound to its parent generator function. So in order to make this work, we're going to have to unwind all of the do level, do sub calls and flatten that out, which I think we can do. Okay, so do level here has two pieces of state that are provided to it, a head and a path. So let's start with that. Right, and with the very first call, head is the outline, so let's initialize that, and path is an empty string. Okay. All right, let's open up do level. All right, we declare the do one sub function. Let's collapse that for just a second and see what do we do. Okay, the very first thing we do is the in level callback. And that now is with our event emitter. So I can say event emitter dot emit in level like that. Okay, next we check to see, is it an include? Oh, look at this. And then we have this piece of asynchronous code to read the include. All right. If head.type is include, then we need to read include the head, and then that's going to give us the included outline, and we're going to call do one sub on the included outline, basically begin the iteration here. And there's an else block. So basically, if our head is an include, then we iterate over the included outline. If it's not an include, then we just start iterating at head. So what I would like to do is this, head equals read include. And then I could come down here and somehow iterate over heads child nodes like that. That's what I want to do. Okay, read include, we've rewritten it to return a promise. And so this is where I'm going to use another JavaScript language feature. Because we're using promises, it means we can also use async functions. And async functions is just a function that returns a promise. So by definition, read include is an asynchronous function. And if I make outline generator also an asynchronous function by putting the async keyword in front of it, or rather I can make outline generator an asynchronous function just by putting the async keyword in front of it, and now it will return a promise. And what that allows me to do is it allows me to use the await keyword inside of it. And what await does when placed in front of a promise or a function that would return a function call that returns a promise is it unwraps the promise. So this returns a promise of an object. Head is now an object, and this code right here is now perfectly valid. So head is the outline, but if it's an include, we read the include, and now head is the included type, and now we can go on about our business of iterating over head's child nodes. So that's pretty nice. Okie dokie. So in level is an include, and then now it's the do one sub. So let's expand do one sub and let's take a look. The very first thing that we do now is we check to see if head.subs is not undefined. I'm going to just say not null with one equals. Not equals to null will actually check not equals to null and undefined, which is 99% of what I mean. In fact, I don't know that I ever have any significant difference between null and undefined in my code. So, and it's easier to write. Okay, if it's not that, and ix sub, oh, an index. All right, let's create that up here too. Let ix sub, we'll initialize that to 0. Okay, ix sub is less than head.subs.length. Okay. So in other words, do we have subs? And then if so, we get the first one. Now here, really what we want to do now is iterate over all of the subs. I'm going to try to do this avoiding callbacks. So let's make a for loop at this point. And we'll use ix sub as my index. So I'm not going to reinitialize it in the loop. But we are going to check to see if ix sub is less than head.subs.length, and then we are going to increment ix sub in my loop. Okay, now that I've done that, I've got my condition here. I don't need it here, so let's just take that out. Now it's if head subs is not null, and then we're going to iterate over all of them. All right, and let's get a sub. Actually, looks like you've got it right here. Let's just bring this line of code up. Okay, and if you don't mind, I'm going to make that a const. And I'm going to make that a const, or break that out into its own line. Okay. Okay, so we have our node and we have our path. All right, now we need to see, is it a comment? Or rather, is it not a comment? Okay, now let's look at this logic here. If it's not a comment, we check to see, is it an include and is it not a doc? In which case, the very first thing that we do is a node callback. So that's going to be a yield. And then we read the include and we iterate over the include. And then when we're done iterating, we pop back up and go on where we were. Okay. Otherwise, we go on about our business. Now, here's our else condition. Else, if it's a doc and the type is an index, add that, then call the node back, then continue the iteration. Else, call the callback. And if our sub has children, then do level for the children. So what I'm noticing here is that in every possible code branch, the very first thing that we do is call the node callback, except if it's a doc and it's an index subtype, then first we do something to the path. So let's do this. Let's grab here. If it's a doc and subtype is index. Okay. Right, because this is not a doc. So if it's a doc and it's this, do that. Okay. Now we can do the callback. We can yield, and we can yield an object that has the node, which is sub, and path, which is subpath. Okay, that's our node callback. That's our for loop body. And again, the way this works is that when we call yield, it's going to pause the execution of this function right here. It's going to go execute whatever's in the body of the for loop. And then when that body ends for the next iteration, it's going to pick up right back off here and continue with the iteration. So in most of our default cases, because we're inside of a loop, it's just going to go right on to the next value. Okay, so that's great. That leaves for us two things that we have left to do. All right, one is handle includes, and the other is handle child nodes. And let's do handle child nodes first. Okay, so you have this code right here, which let me just bring up so we can kind of see it and mess with it. Okay, basically, and if it has children, then we need to go to the next level. All right, but like I said before, if I go into a callback function, I can't use the yield keyword, and I really want to be able to use the yield keyword. So what we can do is we can just modify the values that we're using to control our iteration. Head, path, and index, right? These state variables up here. We just need to make sure that we can return to where we were before. So I'm going to add to all of this a stack. That's just an array. And what we can do here is we can push onto the array the current value of head, path, and ix sub. So now we have saved our state. Now we can assign new values. So we can say head is sub, path is subpath plus slash, and ix sub is -1. And the reason that it's -1 is we're starting at the very beginning of a new array of nodes, but the first thing that this is going to do is when it exits the loop and goes back for its next iteration, it's going to increment. So if we set this at 0, the next time that it comes through the loop, this will get incremented to, or -1, this will get incremented to 0, and then we can begin to iterate over that. Okay. Now, this is a call to do level. The other thing that do level does is it emits the in-level event. So let's toss that event emitter in there so that it does the in-level event. Finally, it has a callback function that is going to do two things. It's going to do the out-level event, and it's going to say continue with the previous iteration. So we do need to make sure that we've pushed stuff onto the stack. We need to pop it. So let's find the end of our for loop, which is right here. And let's do our cleanup. What we want to do is we want to say if head.subs.length actually we want ix subs plus 1. All right, if the index if plus 1 is the length, in other words, if we increment and we're done, there's no more nodes in the current list, and we have stuff on the stack, stack.length is greater than 0. Okay, are we at the end of our list of subs? Do we have something on the stack? Okay, if so, we are going to do the out level callback, which we will use our event emitter for, and then we will pop the stack and reset the values. So that's going to be and we can say head equals prev dot head path equals prev.path, and ix sub equals prev.ix sub. All right. So now if we get to the end of the iteration and there's nothing left on the stack, then we're done. We also need an out level event there. Ooh, out level. So let's actually break this if condition into two spots here. Okay. All right. In other words, are we at the end? Then emit the out event. Is there anything left on the stack? Okay, we don't need to do that anymore. If there is, pop it off the stack and reset the state values so that when we continue in the iteration, we're right where we were when we paused up here to go down a level. So that allows us to continue on with our iteration. Okay, that handles child nodes. Now all we need are includes. And let's look in here and see what do. We call read include, we get the outline, and then we go do level into that. It's actually the same looking code that we do for subs. It's just that it's with the included outline. So what if we do this? Look at this. We need to call read include. Let's actually just, we only need the first part of that though. Okay. What if we have let an uninitialized new head variable? And then we can say if sub dot type is an include. Oh, and what's the exact condition up here? Let's see. That's right, because actually let's go back and look at this. I have this if type is doc, node callback do one, else do the subs logic. So we only do the subs logic if it's not a doc. We only do the include logic if it's not a doc. So I'm going to put the if it's not a doc if condition up here. And we'll put everything into that. And then now I just need to add this if condition here. And I can say if it's an include, new head equals read include. And read include, of course, returns a promise, so I need to use the await keyword. So now that's our included object. I can say else ifs like that, and I could say new head equals sub. And then down here, my condition can become if new head is not null. And this just becomes new head. And now we've handled includes. And we've used the same logic that we did for includes, or for children that we did for includes. And I think that's it. Let's delete these blank lines. Oh, there's something off with my indentation. This code editor doesn't support Dave style closing brace indentions. Okay, so let's look at it here. Head, path, index, stack, in-level event. If it's an include, read the include. Do we have subs? We iterate over the subs. For every one, we get the node and the path. If it's not a comment, if it's a doc, then add that. Oh, yeah, and it's an index, then we add that. Then we yield by giving it the node and the path. And if it's not a doc, is it an include? We read the include. Does it have children? We set new head to that. And if we have a new head, then we push the current state onto the stack. We reset head, path, and ix sub. We emit an end level event. Oh, and I can take this call to do level out. Whoops. Like that. Okay. And then at the end of our for loop right here, if we're at the end of a level, we emit an out level event. And if there's something left on the stack, we pop it and reset that so that it continues to iterate over the child nodes. All right, what else is there? Everything ends in a call to next iteration. We have level complete callback, which is what's passed into do level, right? Which that does the out level callback and the visit complete callback. So up here now, we have the out level callback happens here for every iteration. Oh, except in the case where subs is not null. So let's add, whoops. Sure why I had caps lock on. Let's add a call to out level here. And then that's it. This will run. This is an async, so it returns an object that needs to be awaited or it needs to be thened. Outline iterator doesn't need to change at all. Outline visitor is about to go away, and expand includes now. Currently, it returns a promise. We're going to use the async keyword so that here in my loop, I can use the await keyword off of the thing that I'm iterating, and we're done. And I can delete all of that. And now expand includes sets up its state. It gets an outline iterator. It registers an in-level listener, an out-level listener, and then it iterates over every single node in the outline. And then when it's finished, it returns the new outline. That's, oops. I guess I should pass those values in, shouldn't I? Outline iterator should take the outline, and if I'll stop at docs, and then the generator should pass in the event emitter, the outline, and FL stop at docs. Okay, everything's wired up now. It's not bad. And then the code that actually does the iteration does an actual iteration. This might be faster. I don't know. Not that it matters. Not that it was particularly slow before anyway. No recursion, no callbacks. I don't know. What do you think? I'm kind of curious to know your thoughts. Hopefully you've haven't. Hopefully this was interesting. It wasn't too long. I don't know how long I've been recording. I don't have a timer on here, so I can't tell. But I think it's been a while. Um, anyway, I'll send this to you, and I'll send you the code too. Let me know what you think.